Hello everyone. In this video we're going to be talking about right triangle trig and the law of sines, but in this particular video we're going to be doing the right triangle trig. So just a reminder, right triangle trig is SOHCAHTOA, or sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. And a lot of people get kind of confused whenever you're plugging in here. So just remember that you're only plugging in for the angle in each of these, that's the theta. And then you're also plugging in for what is the opposite side, what is the hypotenuse side, what is the adjacent, hypotenuse, and what is the opposite and adjacent. So you're just plugging in for these values. And if you can see it that way, it will definitely help you out with these problems. So there's two scenarios that we're going to go over. The first scenario is that the angle is right here. So this is theta. This is your angle. It could be like 15 degrees, 20 degrees, something like that. All right, so if we're looking at this angle right here, theta, then the opposite is going to be across from the angle. So here is the opposite side. And you can also say, if you put your finger on the angle, what's the side that you're not touching? So I can see I'm touching this side and this side, so this is my opposite side. Okay, now that I know that's my opposite side, I also know that the hypotenuse is across from the angle. So across from the right angle. So here is my right angle. And across from that is going to be our hypotenuse, which is going to be our longest side. So this is my hypotenuse. Okay, and by default, since this is the opposite, this is the hypotenuse, then this is the adjacent side. And in every single problem, this is what you should be doing. You should label the opposite, the hypotenuse, and then whatever side you have left over, that is your adjacent. So let's look at the next scenario, and that is if the angle is up here. Remember, we're never going to be looking at the right angle. It doesn't actually line up very good with sine and cosine. All right, so the opposite is across from the angle. So if you put your finger on this, the side that you're not touching is going to be your opposite side. So I was not touching this side over here. This is my opposite side. The side across from the right angle, that is going to be your hypotenuse. So this is going to be my hypotenuse here. And if you like the finger trick, you can put your finger on the right angle. I'm touching this side and this side. I'm not touching that side over there. Okay, and the very last thing is going to be labeling the adjacent side. So in this scenario, this would be your adjacent side. So let's look at some examples here. But before we do, let's just note that right triangle trig is only for right triangles. So it sounds kind of, intuitive. But a lot of people get confused and they think that you can use it with any triangle, but it really only works for right triangles. All right, so let's look at this first problem. Solve for the missing side, which is x. So the first thing that we're going to do is we're going to label this figure, what are the different sides. So let's start. Let's look at the opposite side first. I'm going to put my finger on the angle. The side that I'm not touching is my opposite side. So that's going to be this side over here. This is my opposite side, and you can do this trick. Okay, the hypotenuse is going to be across from the right angle, so that's going to be this one over here. And then my adjacent is going to be the last one that I'm going to label, so it's going to be this guy right here. Okay, now what I'm going to do is I'm going to ask myself, which values am I given to work with? If you look over here at the opposite, there's no value that was already there in this problem. So we're not going to be using the opposite. We're going to be using the hypotenuse, which does have a label on it. And we're going to be using the adjacent, which does have the label on it, x, okay? So we're going to be using the hypotenuse and the adjacent. That is h and a. So if we're using h and a, it's kind of hard to see which one you're going to be using, right? So let's say this is actually a h. And now you can see that we're going to be using cosine because it is the SOHCAH, a and h, TOA, all right? So we're going to be using cosine, c equals a over h. Okay, so let's write out this formula. We're going to have cosine of the angle. The angle is 25. Okay, equals the adjacent over the hypotenuse. So adjacent is x. Hypotenuse is 87. Now we're just going to be solving, and I only want to look at the right-hand side of my equation. So if I look at the right-hand side of the equation, I have x being divided by 87. I want to get x by itself, so I'm going to have to do the opposite of dividing by 87, which is multiplying both sides by 87. Okay, now that I've multiplied both sides by 87, these are going to cancel out. So we're going to get x equals 87 times cosine of 25, which we can just write 87 cosine of 25. So now we just need to go see what this is equal to. So we're going to type this into a program and see what that is. And I do want to point out that you only plugged in the angle, and then we also plugged in the adjacent and the hypotenuse. There and there. That's it. So everything else was just already set up for us. Okay, so let's go plug this into a program, and please note that we are in degrees. We can tell because it's 25 degrees. It has that little degree symbol. So let's go to Desmos. We're going to type in 87 cosine of 25. Okay. And whenever we do that, we're going to get 86.234. But I'm going to go ahead and tell you right now, most defaults are in radians. So we need to go make sure that this is not in radians. We're going to click this little monkey wrench tool. And you can see that we are in radians. We have the radians highlighted. So we're going to click degrees instead. And you're going to see this number 86 change to something a little different. And now it's 78.8. So please make sure that you're in degrees and not radians in these problems. So your answer is going to be 78.85 if you want to round it to that. But let's just round it to the nearest tenth, so 78.8. 78.8. All right, so we're going to try out another problem. So let's try out the second one. And the very first step is going to be labeling our sides. So I know that this is the angle that I'm going to be looking at. Okay, so I'm first going to start with the opposite. And the opposite is the one that's across from that angle. So 23 is going to be your opposite. Then I want to label my hypotenuse. That's going to be across in the right angle. Notice there's nothing on this side. It's completely blank. And then the very last one is going to be our adjacent. Okay, so in this scenario, we have our opposite being labeled, and we have our adjacent being labeled. So since we have the adjacent and the opposite, it's easier to write this as OA, and you can see that that is going to be TOA. So we're going to be using tangent equals opposite over adjacent. All right, so let's plug in our values. We're going to have tangent of the angle equals the opposite over the adjacent. So our angle is 18. We're going to plug that in here. Our opposite side is 23. And our adjacent side is x. Okay, so we have this equation here. And I want to show you how you can solve this out. And then I'll show you a shortcut that you can use here. So I'm actually going to grab a sticky note to show you how you can solve this. All right, so here's one way you could solve this. We have tangent of 18 equals 23 over x. The only way to get x out of the denominator is by multiplying both sides by x. So let's multiply this side by x. Let's multiply this side by x. The x's are going to cancel out of here. We're going to get x equals x tangent of 18 equals 23. And then we'd have to divide both sides by tangent of 18. So we get our final answer, x equals 23 over tangent of 18. Now, this was kind of a lot of solving steps here, but what you'll notice is that what actually happened is we just switched x and tangent. Okay, so if you look up here, if we switch x and tangent, we will get to this final answer right down here, x equals 23 over tangent of 18. So that's the trick that we're going to use, and you can use this for any variable that you're trying to solve for in a denominator. So we're going to say x equals 23 over tangent of 18. All right, we're going to go type that into a program and see what this is equal to. So 23 divided by tangent of 18. And like I said, please make sure that you're in degrees and not radians. This is radians. You get negative 20. That's not correct. And degrees, you get 70 point, and let's just say 70.8. Okay, 70.8. Okay, so I just showed you the two methods of solving. One is that you're going to be multiplying the side by cosine or sine of the angle or tangent. The other one is switching the variable with the thing over here. So there's really only 6 scenarios that you can get here. You can get the number times sine, number times cosine, number times tangent. That's like this scenario up here, okay? We have number times cosine of 25. That's like these scenarios. So this is one thing that you can get. The other thing that you can get is if the variable is in the bottom here. So that's number over sine. So this is number over tangent, number over cosine, or number over tangent. Those are the only scenarios that you should get for these problems. If you get another scenario, you have done something wrong. So please go back and check your work on your answer. All right, hope that you guys enjoyed this video. Please stay tuned for the next video where we talk about the law of sine. Goodbye.